This is problem 4 of the Operations Research Final by Justin Nathanson. So this problem, we had to use branching and bounding to solve a maximization problem with 4 decision variables subject to 3 constraints. All of the decision variables must be greater than or equal to 0, but only x1, x2, and x3 are forced to be integers, while x4 can be anything continuous. So the first step to branching and bounding is to initialize the problem, which for a maximization problem we set immediately the z to negative infinity, and then we solve the relaxation of the problem in which we remove the integer requirements from all decision variables. And this problem requires doing the simplex method multiple times, so for this we use the online calculator linked below. So when solving for the relaxation of the first problem, we ended up getting that x1 is 2.1333, x2 is equal to 0, x3 is equal to 3.733, and x4 is equal to 3.0667 for a max value of z is equal to 197.333. Moving on from here, we start our first iteration of branching and bounding, in which we force an integer. We force the decision variable x1 to become an integer, and we divide it into 2 subproblems where x1 is less than or equal to 2 or x1 is greater than or equal to 3. We chose these because the value of x1 in the original relaxation was between 2 and 3. So from this, we ran the simplex method twice, and we found that both scenarios resulted in feasible, fathomable solutions. However, we found that when x1 was equal to 3, z had a larger value, so we decided to continue on with that path. And in this situation, this worked out, but if we were to find no feasible integer solutions farther down in this path, we would have to go back to subproblem 1.1 and branch from there. So this is just a visual representation of what we just did in the last problem, where we moved from the relaxation to solve problem 1.2, and from there we're going to continue with iteration number 2. So for iteration number 2, we have to now look at decision variable x3. We chose to skip decision variable x2 because it was already an integer at value 0. So from the subproblem 1.2, which I'll go back to right now, we can see that x3 is equal to 5.25. So we branch from there and not from the original relaxation. So when x3 was given as 5.25, we break that up into 2 subproblems, subproblem 2.1 and subproblem 2.2. Again, we chose x3 to be less than 5 in subproblem 2.1 because x3 was equal to 5.25 in iteration number 1, and we chose subproblem 2.2 to be less than 6 because or greater than 6 because x3 is between 5 and 6. So from this, we ran the simplex again, except we added the constraint that x1 is equal to 3 since we already established that was true. And we found that if x1 is equal to 3, x3 cannot be greater than or equal to 6 because it violates constraint number 3. However, if x3 is less than 5, it works out perfectly, in which we have a feasible solution that satisfies all integer value requirements as well as all constraints and conditions, leading us to have our final answer of z is equal to 195 with x1 is equal to 3, x2 is equal to 0, x3 is equal to 5, and x4 is equal to 0.5. What's interesting about this problem is that if we continue and apply the integer requirement to x4, we see that, in fact, we get the exact same optimal solution where z equals 195. However, in the updated one, where if x4 was required to be an integer, x4 would equal 0 and x2 would be equal to 1. So just to recap, with the given problem presented, we know that at the final solution, x1 is equal to 3, x2 is equal to 0, and x3 is equal to 5, with x4 equal to 0.5. However, if x4 was required to be an integer, we would arrive at the solution of x1 is equal to 3, x2 is equal to 1, x3 is equal to 5, and x4 is equal to 0.